Thanks, Lauren. Okay, well, terrific. I'm glad we're starting on time. Thanks, everyone, for coming and joining us. You are in the Are We There Yet Quantum panel. So today we're going to be hearing from three distinguished guests, pioneers in the field of productizing quantum applications. And we're going to hear a little bit from them about what's been happening in the field, their own experiences, and what it's like to take quantum technology and leverage it for production applications and bringing business value to our own businesses and to our customers' businesses. So first off, I'm going to ask, my name is Thom. I'm the Vice President of Product Management at D-Wave Systems. I'm going to ask each of our panelists to introduce themselves, to tell us their names, their role, and their place of work, and also to talk just sort of as a an icebreaker here about what quantum application you're working on right now, or what quantum application you're excited about. So Hans, I'm going to go in alphabetical order on first name here. So why don't you go first?
Sure. Thanks a lot, Murray. Thanks for the invite. Really excited to be here with everyone. So my name is Hans Melo. I'm the CEO and one of the co-founders at Menten AI. My background is in physics, and then switched to machine learning, computational neuroscience for my PhD. And after that, I actually kind of went back to physics and sort of landed in between with quantum computing. And so we're working on quantum optimization, specifically for drug discovery for the past couple of years. Started Menten AI, we've been working on designing proteins, specifically peptides for different therapeutic use cases.
Thanks, Hans. Thanks. All right, Sam, over to you.
Hi, everyone. Thank you, Murray. So I'm the CTO of Multiverse Computing. We're a fintech applying quantum computing to really hard financial problems. So I'm actually also from a background in physics. I have a PhD from University of Southampton in the UK. Yeah, the type of problems we're tackling are things like investment optimization. We're also delving into these really difficult simulations of complex economic networks, which is super interesting, and actually giving a talk on that next week. And also applications more on the machine learning side, like applying quantum computing to enhance neural network for exotic option pricing. So also really exciting area.
Awesome, Sam. Okay, thanks so much. And Sara, over to you.
Hi everyone. I'm Sara Felloni. Nice to meet you and very happy to be here. I'm from Italy. I'm quantum and accelerated computing lead at Data Reply, the company in the Reply group, which specializes in big data, artificial intelligence, and quantum and accelerated computing. My background is in applied mathematics with a PhD in quantum computing, and I am leading Data Reply's quantum initiatives from a business and management perspective.
Awesome, Sara. Terrific. All right, so we're going to jump right in. And one of the questions here that I think is probably going to be on everybody's minds is, when you're working on developing production quantum applications, it's not just a matter of the technical challenges of doing the development, using the tools, and applying the technology. There's also building a business case. You need to demonstrate business value, and then you have to make that case for your company. So for each of you, there was a point in time where a case was made, and and that case was about that practical quantum computing applications were a priority, that you could use them to build business value. And that was accepted. So knowing what you know now, what would you have told yourself at the beginning of your journey to help that case clearer sooner? And Sam, I'm going to go to you on this one first.
Okay, fantastic. I think that early on, looking at quantum computing, I was discouraged by the timelines. So we're talking back during my PhD, so it started in 2013, I guess. Discouraged by the timelines for the first error-corrected qubit and things like this. And I think my quantum computing journey really started when I started learning about NISQ algorithms and analog machines. I think at that point, for me, there's a real turning point that took place, because I understood that there's a lot of very near-term gains to be had with quantum computing, and this is the type of gains that we've really been pursuing at Multiverse. So I think if I was to be able to step into a time machine now and talk to my 2016-ish self, I think that's what I'd say to myself. Not only well, that there's things outside of Shor's algorithm and possibly with a better, like a closer to date market value.
Okay. So really kind of like delving into some of the details about how technology was being developed and that there were sort of nearer term opportunities with some of the new technologies. Sarah, what about yourself? What would you kind of tell yourself in terms of going back to your early journey and helping yourself build a business case for quantum applications?
Well, in this regard, I consider myself very lucky because I joined Data Reply at the beginning of 2020 when a strong quantum computing group already existed. So I started from a strong basis and we defined a clear roadmap and ambitious goals to expand both our knowledge, but also our customer proposition. And we always had in mind that quantum computing applications were to be our main priority, as long as we kept also in mind that our ultimate objectives was and still is to bring concrete and measurable benefits to the customers, and right now, not just with a long-term perspective. So basically, we strongly believe that every innovation needs to be integrated in organizations and its value needs to be perceived easily and immediately for this innovation to be successful. And since the beginning of my quantum journey started in academia with my PhD studies, I had a more abstract, more theoretical perspective. And to have all these concrete goals always in mind is basically what I would tell to my past self.
Yeah, okay, that's a great point. And I think, I think that's a really identifying a key challenge here is that it's not enough for the technology to just have potential 10 years out in the future. And I think too many people rely on the fact that that's going to be the case. We really need to be able to show business value for customers in the nearer term as well. And that is also itself challenging. So Hans, as you're thinking about this and your journey and how that case was made at Menten, what are your thoughts and perspectives?
Yeah, so I have a similar experience to Sam in many ways, and also to Sarah, actually, interestingly enough. But the way I think about it, I think, if we want to build a business case, we need to identify a problem that is a significant problem, right? If we solve this problem, it would mean a lot for the field, for the industry. And then we need to say, okay, so this is the nail. Now, why is quantum a good tool to actually tackle that particular issue we have, right? And going back to what we do at Menten, we realize that optimization, combinatorial optimization happens to be a key problem, a key challenging when you go into drug discovery. And that is the case for small molecule, large molecule biologics, and for peptides. Now we chose to focus on peptides and protein design because we have a lot of expertise in that field and we saw huge potential as well. And so for us, it was combining those two together. What I would tell to myself at the beginning of this journey would be, learn to speak just simple terms, layman language. Because I think a lot of the challenge I had at first communicating with investors and people that were interested was like, I was speaking scientific mathematical terms that sounded nice and buzzy and fancy, but at the end of the day, you really have to communicate simple terms. Why does this matter? What problem are you solving? And so, it took me probably a couple of years. I'm still working on it, but just get the language to the level where I can communicate and people can recognize, oh, I get it. That's why it's important. That's why quantum can make a difference.
Yeah. No, that's an excellent point. I mean, I think all of our jobs are to take, in terms of bringing business value to our customers, is about taking some complex thing and then making it simple, right? Bringing value to them in a clear story. I mean, certainly I remember when I first entered into quantum computing, that was how my family members would react when I would tell them what I was doing. And they'd be like, maybe you can break this down into some simpler terms so that I can understand, like, there's a marketplace, you're bringing some value to people, who are those people and what are you doing? Okay, so one of the things I'm wondering here is that, quantum computing is a technology that's been working along a whole series of milestones for the past 20 years, starting with a lot of research milestones and really kind of getting towards some business milestones. From your perspective, as you've been working with quantum computing, and also for the benefit of the audience, what relatively recent development do you think in the space of quantum computing has been most impactful for delivering quantum applications? Something that really kind of like is an accelerator or unlocks the potential or just makes it easier to put it into practice. Sara, I'm going to start with you. What are your thoughts here?
Well, I focus in our group, we focus on quantum optimization. So my answer can be easily guessed, I think. I believe that one of the most impactful development in quantum computing is the announcement of the world's first commercially available quantum computer by D-Wave system, D-Wave 1. I remember when it was unveiled in May 2011, operating on a 128 qubit chipset and exploiting quantum annealing. So it was really a great news, a general method for finding the global minimum of a function using quantum fluctuation to solve optimization problems. And I remember for me, but also for my colleagues at the time, it was the first concrete signal that quantum computing could go out from the laboratories, from academic research, and reach the market and reach a real production application. So it was just a matter of time because the race to build larger and better quantum annealers and quantum computers started and steadily continued. And we are seeing more and more insights and maturity in the field. And this also allows for more and more advanced production quantum applications today.
Mm-hmm. Yeah, I like the way you put that, sort of the opening bell in the race, and then sort of relying on our sort of economic system, our technology sector, to kind of like everyone sort of pushing themselves, developing the technology. Once that becomes commercially available, that really is an opportunity for the technology to get accelerated. Hans, what about yourself? What do you think about an event here in terms of that kind of impact?
Yeah, I guess the availability of these hardware systems online and on the cloud, so like D-Waves, other have a lot of similar, so just making those systems available so that companies, individuals can go in and begin to test and actually begin to work on a specific application into industry. And so for us, being able to actually have an API interface where we could actually send jobs and begin to explore that and actually apply that in real world scenarios, that made a huge impact because we could move from this is in theory we could do this, we have an algorithm that could one day do this, to actually being able to do it, right? So I think that is the beginning of the true application of quantum technology in industry. So I think just the availability of those systems in the last couple of years, has made a huge difference.
Yeah, I think that touches on a key point because a lot has been said and sort of made about the fact that if you understand quantum mechanics, if you think you understand quantum mechanics, you probably don't understand quantum mechanics. And one of the things that's interesting about the way quantum mechanical systems work is that they're different than the way things work in the world that we interact in as babies and as small children. We're interacting with the world, ourselves with our hands and everything like that. And once quantum computing systems come online and are easily and readily accessible for companies, that's sort of many people's first opportunities to actually interact with a quantum system and see what it can do. So that's certainly if quantum applications are going to get built, developers and business leaders are going to have to actually be able to interact with the technology and get access to it. So that's a really interesting point. Sam, what about yourself in terms of an event for impact and delivering production applications?
Right. Well, I think that, so my case is a little bit different from Hans and Sara because we're not specific to optimization. However, I think that I'm going to go with a very similar answer, and Maria, you put your finger on it when you said ease of use and ease of access. I think we're still in a field that's very, very research heavy. And so the key to delivering production ready applications, particularly applications that create commercial value, is to just be able to explore lots and see what sticks, basically. And one problem that we're having in quantum computing at the moment is that the learning curve is extremely steep. But recently we've seen like tools appear where you can automatically tune hyperparameters, like for instance, the annealing time on D-Wave. You can automatically implement certain error mitigation or certain, I've lost the word, but it doesn't matter, error mitigation tools. And basically this is allowing quantum computing libraries to just become available and to be able to use quantum software through these very standard interfaces. So the result of that for us is that it's now realistic to be able to produce a demo on many products, demos on really short notice and really zero into products that have commercial value.
Mm-hmm. Okay, so let's just look at sort of where we've been going, in terms of like, the case to be made. We're talking about like the value that can be obtained with early technologies, right? And setting concrete objectives for ourselves as we're trying to demonstrate that value for customers. And then also, the fact that the technology has become commercial and become easily accessible over the cloud so that lots of people can get access to this technology. So my next question kind of builds on this. In your journey working with quantum computing, you are looking at your application problems, and Hans, you touched on this point earlier. How did you know which problems were going to be suitable for the technology, or what process did you use to determine this? Because I think this is a question on a lot of people's minds. So Hans, let me start back with you here.
Sure. So I think that is the most important question, right? Identifying the right problem to solving quantum with quantum technology. So in our case, I already had a background sort of in optimization, and I was familiar with the different techniques that were available. And when I was first a student in physics, people talked about one day being able to solve this problem using quantum computing, right? And people would theorize about the different advantages, types of problems, and different algorithms that could be developed, that some already had been developed. But the thing is, I think what made the most difference is seeing that problem in some real world application, right? Taking it from an abstract mathematical, purely scientific interest to, okay, where can we actually use that kind of technology and apply it? And so that's where, working with other people from these different disciplines really comes together. And for us, for me personally, I was very lucky that I was collaborating with one of my now co-founders, Vikram Mulligan, who understands protein design extremely well. So he's one of the core developers in the field, and he had written different algorithms for solving this kind of optimization combinatorial problems specific to designing proteins and designing peptides. And so the conversation we had was really interesting because, for one thing, the language didn't match, right? He spoke a different language than I did. And so we have to reduce the language to sort of a 5-year-old. Like, just draw the simplest example that you can think of, right? And so when we're able to do that and connect the dots there, then we were able to extrapolate, expand the language, and establish a common language, and actually begin to work on the actual problems. Right. And so for us, it was really a matter of, we have proteins, there's a huge combinatorial space. We need to find the best combination of the molecules, of the different atoms, so that we maximize, the chances of succeeding. Or, in a simple energy problem, we need to identify the state with lowest energy, right? So it's just a matter of matching the different language. Once we were able to do that, we were able to then apply the technology, put together an algorithm, work on implementing this on hardware, and build from that. But I think that the key challenge was really, identifying the problem and then building the tools to actually implement it.
That's a really interesting point. I kind of I'm hearing two parts there. One is sort of, seeing the technology actually used in practical application, is really important because it takes it out of the laboratory context and puts you in the context of, oh, okay, we're going to turn quantum mechanics into useful work. It's one thing to boil water on the stove and see liquid become gas. It's another thing to see that put into a steam engine and pull thousands of pounds of steel on a train or something like that. And then the second part is, bringing people together and maybe stripping away some of the details of the problem so you can get down to like, what is the core aspect of it that's giving you a challenge. So Sara, hearing that and thinking about your own experience here, what would you say in terms of that process that you're using for finding where the technology is suitable, or experiences you've had in the past that have helped you to determine that?
Yes. So the expertise of our team covers all the main areas of quantum computing, which can have a practical application for business right now or in the nearest future. So I'm mentioning hybrid quantum, classical computing, quantum optimization, which I already mentioned, quantum security, quantum machine learning, and so on. So for a new customer, it can be easy for them to get lost in too many opportunities. So for this reason, we are very careful to cultivate and expand not just our technology and programming know-how, but also we put much focus on consulting and business strategy for quantum computing. So we draw from business strategy, program management, and business analysis, classical approaches and methodologies. And we have developed and are still developing a systematic and standardized approach for quantum business strategy. So we can help customers identify where they need or should invest with quantum computing in their organizations, which problems are most suitable to be addressed by quantum technology today or in the future, and where the main benefits can be expected. So in this approach, we analyze many factors, such as the mathematical structure of the business problems, the project risks, the expected return of investments, the customer's technology and business level of readiness for such innovation, what could facilitate or delay the quantum adoption of this solution in the business. And then, together with the customer, we define a system of priorities and we perform a weighted customized ranking of the initiatives in terms of suitability. And finally, we define with the customers a customized specific roadmap for implementation for these initiatives.
Mm-hmm. Yeah, that's a good point. I mean, in that, Sara, that touches on an important point here, which is that, businesses, as they're looking at technologies, I mean, they're evaluating quantum technology, they're learning about quantum technology, but that's in the context of technologies more broadly in which they're making that evaluation. And so many of them are probably facing a decision, should I try to build this myself, or should I purchase the capability from someone else, or in your case, sort of building it yourself, but phoning a friend, right? Getting someone with help and who can help with that. Because sort of what you're saying is that there's a strong approach to be made by investing in your team, investing in the time it takes in the various fields it takes to be able to break these problems down. And that investment is not one that everyone's going to be able to take, themselves, right? So being able to consult with teams, get that expertise, have that important, I mean, the other thing I'm hearing that I think everyone is going to have to do is have that really important customer interview about, their objectives and the problems that they need to solve. I'll be interested in, is there any particular example of an engagement or a customer conversation that kind of comes to mind, Sara? Where that discovery process, like I was thinking about the point that you made earlier about like helping to really establish with the customer their core objectives, what they want to demonstrate for business value. Is there any particular example in your recent past that that you think kind of exemplifies, making that objective clear so that it's not just an investigation for technology's own sake?
Yes, we usually, as I said, start from understanding the customer's needs and opportunities, but also making the customer understand that there are problems better suited or opportunity better suited for investment in the short term and other in the long term. So we want to bring quantum computing to our customers, of course, but we want to bring it in a concrete application-based approach. And so A recent example that comes to mind is when we have offered these consulting services to make the customer understand that while, for instance, application in quantum machine learning can happen in a short term, but they are not yet market ready. Instead, if they focus on quantum optimization, hybrid computing, they can bring improvement in their business process starting from today. And so, since we often talk with innovation or ICT stakeholder, if they can also show their business colleagues, their business stakeholders, that there can be a good benefit in one area, then it's much easier to promote further investments and future projects all in other areas. And this is what we intend by having a ranking of these cases in terms of business readiness, technological readiness, suitability for the approaches. This is also why we have recently developed what we call a business accelerator. It's a software component that is aimed at facilitating projects in quantum optimization and aimed at facilitating the use of both classical and quantum hardware. So it's meant as a way to make the customers understand where they can find immediate benefits in their projects, in their business.
Yeah. Okay. Thanks, Sara. Thanks. Okay. So Sam, I think you've also had some similar experiences working with customers, helping them see that advantage. Finding that sort of first point, and then talking with them about further work in terms of further investing and building out and working with quantum computers and applications. So again, what I'm going to touch back on the question, but maybe you can also comment on some of those points that Sara was making here in terms of like, how did you determine which problems were suitable, or what process did you use? What do you bring with your customers?
Absolutely. Yeah, I think actually we've got an interesting story when it comes to how we zeroed in on applications, essentially. So my co-founders and I didn't start out as Multiverse. We started out 4 years ago as a not-for-profit called the Quantum World Association. And we had quite significant contacts within industry, especially in Europe. And they were all coming to us and saying, when will quantum be a thing? When's the right time to invest, basically? And so we set out to answer this question and really apply quantum to industry. And I think this really comes back to what Sara was saying, that the philosophy behind this is that if you're going to apply quantum to industry, then it has to be customer driven. But also some of the time you have customers coming to you and saying, we'd like to do something in quantum, we just don't know what. So we also need to develop that ability to guide the client towards interesting problems, basically. So what we did as part of the Quantum World Association was to systematically look at all verticals for quantum computing within finance. So there was a lot of them, but a finite amount. And we published a paper that's out there, a review that came out a few years ago. But especially in doing this work, we identified some low-hanging fruits, and we also identified more ambitious, higher value projects. And so when we decided to found Multiverse, we actually started out with a very clear technology roadmap. And as you said, Murray, we co-develop all our products with clients. And some of those low-hanging fruits, like a very successful portfolio optimization tool, caught some interest of some clients. They came back to us, and currently that tool's with them in pre-production at the moment, and we're exploring more ambitious projects in parallel at the moment.
Very cool. Very cool. So yeah, I mean, the interesting thing about this is that there's sort of this common exploring, the technology is really exciting. It has this explosive potential in terms of, unlocking new problems to solve. And each of you in very different fields, in industrial optimization and, looking at financial applications, and also in protein design and therapeutics, started doing that exploration and found applications in each of your spaces where, exactly like you were saying, Sam, there's sort of low-hanging fruit, and there's also opportunities for high impact, high value applications as well. So that, I think, is going to be heartening, because as pioneers, a lot of, there are stages in the technology that will be developing along. And I think a lot of the folks in the audience are going to be looking to your experiences and then saying, okay, there are opportunities here there are many opportunities, to find these application spaces. So oh, great, we've got a question here. And this one is for you, Hans. There's a mention here that, peptides are really large molecules. Is reliable quantum computing available today for the kind of work you just mentioned?
Yeah, thank you for the question. So peptides are large compared to small molecules, but they're smaller compared to much larger proteins. So it's all relative, and depends a lot on the application, what you're actually trying to do, right? So if you're trying to do, quantum chemistry simulations on quantum computers for peptides, well, that's not going to work, right? So we're not at the point in the technology where we can do that. However, if you're trying to optimize the conformation of peptides, where you don't take into account every single atom individually on the quantum computer, but rather you take the amino acid chains, then all of a sudden the problem becomes a lot more trackable. And that's one of the things that we realized, and we've been able to leverage to actually use quantum computers for solving and designing peptides and small proteins today. Without a question, is the early days. As the technology develops, it will, open a new space, new possibilities. But we are at the point now where we can begin to use these tools in real world scenarios, real world use cases for designing peptides. So, yes.
Awesome. Okay. And Sam, I think you mentioned a paper written about, quantum computing use cases in finance. We have a question here about, where can they find that resource, and is it free to access?
Absolutely. Yeah, it's up on the archive. I believe the title was Quantum Computing for Finance Overviews and Prospects. So that should have come out 2018, I believe, with both my co-founders, Roman Oris and Enrico Lisasso. Okay,
great. And we have another question here, which is like, what applications do you expect to be the first to enter regular business production use? But I know, that some of you are already using some quantum applications to do sort of production applications. But I think the second part of the question is a really good one. What will get them over the winning line? So, if you're working on things in production, what has got them over the winning line, or what do you think will be the thing to get you there? Sarah, do you want to comment on this first?
Thank you. So yes, we are already dealing with the production application of quantum computing, or hybrid quantum classical computing. We are seeing that the business sectors that are most successful in adopting this solution and scaling this solution to full production level are finance, logistics, energy, and manufacturing. I'm still talking about quantum optimization because they have in common that many of their core processes require algorithms whose complexity is always a huge obstacles. They require too long time to compute the solution, or the too high complexity prevents from having a full modeling of the problem, and so a high quality solution of the optimization. So in this area, we are seeing that hybrid approaches are not just on pair with the existing classical solution, but they are already surpassing existing solution and bringing considerable improvement. Depending on the problem and on the customers, we are seeing that against the agreed KPIs they define for us, we can reach improvement ranging from 5% to 10, 15, 20%. So very huge improvements that brings concrete benefits when you consider these improvements in the whole business perspective.
Okay, thanks. And Hans, thoughts to you about, first to enter regular business production, or what gets an application over the finish line, in terms of getting into production?
Yeah, so I think the first thing you need to do is to understand the capabilities of today, what we are able to do, and within the pipeline that you're developing, understand what part is ready for quantum today, and what part we really need to do supplementary, right? And I think this idea of quantum is going to replace CPUs, all this other hardware is quite misplaced, right? And in reality, it will take a more of a role as a co-processor, right? In the same way that the GPU didn't replace the CPU, right? We just learned a specific use case for this technology and we apply it. And so the same we see for quantum in our space, and I would bet it's the same for any space, right? So we identify an area where we could use a quantum co-processor, if you will, a QPU, to solve a specific optimization problem. And then we realized, well, actually, the technology, here's where it stands today. Are there other things that we can do to make it go a little bit further? And so that touches back on some of the hybrid approaches, NISQ algorithms, hybrid algorithms that we develop to actually, implement quantum in conjunction with other traditional approaches. And so bringing those two together actually allows us to make it a useful part of the pipeline for, in our case, designing molecules.
Yeah, that's a good point. I mean, and building on what Sara was saying here, when classical computing became developed, it's not like they had an application where no humans were involved, where human calculators all of a sudden didn't exist, right? They were part of a human workflow. And so in the development of quantum computers, I mean, we have to keep in mind, we've got the context of all the classical technology around us. So it's really about where is their place within the workflow. And once you're using it in that way, that actually kind of accelerates and gets you to that point. Sara, I'm happy to hear what you're saying in terms of being able to make concrete demonstrations of acceleration right now. Now, there's a question here about where we are in the Gartner hype cycle, which I was like, I've heard that term before, but I had to look it up, which was really about, are we in the technology trigger? Are we at the peak of inflated expectations? Are we at the trough of disillusionment? Or are we on the slope of enlightenment towards the plateau of productivity? So I just summarized that so you didn't have to Google search it. But where would you say we are in that life cycle from your perspective? Hans, I see you unmuting. You ready to make a comment?
Yeah, I think, honestly, I think we don't know exactly. I would say that depending on who you ask, we're at the peak or we're still at the bottom, right? We're certainly not over the peak. I think there's certainly some hype around, but I think most of the hype, it's some is far-fetched, misplaced, but certainly within the circle, it's very easy to understand. Okay, this is what quantum is actually useful for. And these are applications that maybe not really suited for quantum, not today and not in 10, 20 years, right?
Okay.
So my naive, I would say we're a bit over the hype, I would hope.
Okay, yeah, I think fair enough. I mean, and the other thing is looking at that, that's also, there's a good perspective of, are you looking at the quantum computing industry more broadly, where there probably is a lot of hype? Or are we looking at towards individual experiences, because that might shift the Gartner hype cycle? I'm hoping, at least given our discussion about your experiences and using this in production and bringing business value to your customers, that we're making steps along that slope of enlightenment. Sam, final comments?
Yeah, I'd love to jump in and build on what Hans was saying. I think obviously it's super loaded question, really hard to place ourselves on the hype cycle without like looking back into the past. But I'd say there's kind of two axes to this, to the hype cycle, which is on one hand, how much hype there is. And I'd say there's definitely a lot of hype around quantum computing. But on the other hand, are we actually producing like applications of, is there actual industrial impact? And at this point, I think that we're starting to see that the answer is yes, that quantum computing is also, despite the hype, producing applications of commercial value. And I think that needs to be taken into account as well, that we're crossing that turning point at the moment.
All right, well, Sarah, we're right at the end. I'm going to give you the final word. What are your comments about our position on the hype cycle?
Yeah, I agree that it depends who you're asking this question to. But since I'm an optimistic, I am saying that we are at the beginning of a very interesting and very promising race toward improvement of technology. But of course, we need to be very aware to set the right expectation, because if specialists and press and other experienced roles in the sector are not clear on what quantum computing is meant to do, what can do today, what can do in 5 years, 10 years, 20 years, then we risk to not meet the expectation we set, and then to discourage people and businesses. And this would be the most negative outcome, that people lose faith before quantum computing is able to reach the right level of maturity to deliver all its promises.
Terrific. Well, thank you, Sarah. Thank you, Hans and Sam. It's been such a pleasure talking with you this morning. And thanks everyone for Quantum.Tech. Thanks to Quantum.Tech and the hosts for having us here and hosting this panel. And thanks for all of your time. It's been a real pleasure speaking with you all.
Thank you.
Thank you. Thank you.
Thank you.
Bye-bye.